Have you ever felt like you're getting whiplash from health news? You know, one week coffee is a superfood and the next it's public enemy number one. It is so confusing. But what if I told you this confusion isn't random at all? It's actually a predictable and kind of fascinating part of the scientific process. Today we're going to pull back the curtain on medical studies to figure out why the headlines are always changing, and more importantly, how you can spot the real deal.
So you've definitely seen a headline like this, right? It's scary, it grabs your attention, and it probably makes you look at your morning cup a little differently. But then, just when you're thinking about switching to tea for good, bam! You see this one, the complete opposite. So what is going on? Is science just making stuff up as it goes? Well, no, not at all. The funny thing is, both of these headlines could be based on totally real, legitimate studies. But the type of study they're based on, well, that makes all the difference. Okay, let's just dive right in. See, unlike a chemistry experiment in a perfectly controlled lab, studying human beings is messy. It's complicated. We can't just ethically lock 1,000 people in a room and force them to smoke for 20 years to see what happens. And that's where a field called epidemiology comes in. It's basically the science of finding answers in these messy, real-world conditions.
So, a lot of the time, the first thing researchers do is just watch. They act like detectives at a crime scene, looking for patterns and trying to gather clues without actually interfering. We call these observational studies. One way they do this is with something called a case control study. You find a group of people who already have a specific disease, let's say lung cancer, and you find a similar group of people who don't. Then you look backwards into their past and you ask, okay, what was different here? Maybe you find out the group with cancer smoked a lot more. It's a really quick and efficient way to find clues, especially for rare diseases, but it has a big weakness. Our memories aren't perfect. It's something scientists call recall bias.
Think of it exactly like this. The crime has already happened. The disease is already there. You're the detective showing up on the scene, trying to piece together what happened by interviewing everyone about what they were doing before.
Now, a much more powerful type of observational study is the cohort study. This time, you start with a huge group of healthy people, your cohort, and you follow them for years, sometimes even decades. You track their habits, what they eat, how much they exercise, and you just wait and see who gets sick over time. This is way better for showing that a certain behavior came before a disease developed. So sticking with our detective analogy, this is totally different. Instead of working backward from a crime scene, you're now identifying a group of potential suspects before any crime has even been committed. You're basically watching their every move for years to see how their story plays out. It builds a much, much stronger case. And this table really lays out the trade-offs perfectly. Look, cohort studies give you much stronger evidence for cause and effect, but man, are they expensive and slow. We're talking decades of work. On the other hand, case control studies are way cheaper, faster, and great for studying rare diseases, but the evidence they give you is just, well, it's not as solid. Researchers always have to weigh these pros and cons. But what if you need the absolute strongest evidence you can possibly get? For that, we have to move past just watching people. We need to actually step in and test something. And that brings us to what's known as the gold standard of medical research. This is the randomized controlled trial, or RCT. And here's the magic. Participants are put into different groups. Say, one group gets a new drug and the other gets a placebo, completely at random, like flipping a coin. And that one simple act of randomization, it is the absolute key to the whole thing. This is why it's so powerful. In an observational study, you might see that people who drink coffee get less heart disease. But hey, maybe people who drink coffee also happen to be wealthier, or exercise more, or eat healthier. These hidden factors are called confounders, and they can totally mess up your results. But in an RCT, randomization is like hitting the shuffle button. It mixes all those factors up between the groups, so on average, the only real difference left is the one thing you're actually testing. It's brilliant.
Now I know this might all seem a little academic, so let me tell you a famous real-world story about what happens when we rely on weaker evidence for way too long. Let's talk about hormone replacement therapy. For decades, and I mean decades, the medical community believed that giving hormone replacement therapy, or HRT, to postmenopausal women was a great idea. And they had good reason to think that. We're talking about more than 50 different observational studies, all pointing to the exact same conclusion. HRT seemed to protect women from heart disease.
Just look at this timeline. For nearly half a century, the evidence felt solid. It felt consistent. Then, in 2002, the results of one single massive RCT, the Women's Health Initiative, came out, and it was a complete bombshell. The gold standard evidence showed that HRT didn't just not protect against heart disease, it actually increased the risk, along with the risk for stroke and breast cancer. The entire medical world was stunned.
So you have to ask yourself, how? How on earth could more than 50 studies get something so fundamentally backward? Was all that earlier research just junk? No, not at all. It just fell into a classic trap.
The answer was confounding. It turns out the women who chose to take HRT back then were already healthier and wealthier to begin with. They saw their doctors more often, they had better diets, they were just a healthier group of people overall. It was their healthier lifestyle, not the HRT, that was protecting them. The observational studies couldn't see that, but the RCT, by randomizing women, finally untangled that false connection. Okay, so the HRT story is a huge lesson. It proves, pretty dramatically, that not all scientific evidence is created equal. So how can we, people who aren't scientists, possibly make sense of it all? Well, luckily, researchers have a pretty handy tool that can help us sort through the noise.
The trick is to stop thinking of all studies as being on the same level. Instead, you need to think of evidence like a pyramid or a ladder. Some types of studies give you a much stronger foundation for making claims than others. And here it is. This is the hierarchy of evidence. Right at the very top, the absolute strongest evidence you can get is when you combine the results of multiple high-quality RCTs. Just below that, you have a single well-done RCT. Then, as we go down the pyramid, we have our observational studies. Cohort studies are stronger than case control studies. And way down at the bottom, you have weaker stuff, like simple surveys. This pyramid is your mental shortcut for judging a health headline.
But, and this is a really important but, we can't just blindly follow this pyramid as if it's a perfect rule. There's one last layer of nuance here that's absolutely crucial for understanding how science really works. So here's the deal. Quality matters a lot. A really small, poorly designed, sloppy RCT might actually be less trustworthy than a massive, decades-long, meticulously run cohort study. So this hierarchy is an amazing guide, but it's not a rigid set of rules. You still have to ask, was this specific study done well? And this really gets to the heart of it all. I love this quote. It says that figuring out if one thing truly causes another isn't a simple math problem. It's a judgment call. It takes expertise, deep knowledge, and the skill to look at all the available evidence and see the big picture. So the next time one of those shocking health headlines pops up on your phone, you'll be ready. Instead of either freaking out or just ignoring it, you can take a breath and ask one simple question. What kind of study is this based on, and where does it sit on the hierarchy of evidence? Honestly, just asking that one question will make you one of the smartest, most informed people in the room.